This is video 4.5.3, and the goal is to understand how to find rules for sine and cosine waves. So this video is actually going to mimic what video 4.5.1 does, because what you did in 4.5.1 was and is going to help you find the rules for sine and cosine waves. So here's what you want to remember from 4.5.1. The general forms of the equation as you have in your notes, and if you know that the amplitude is always the absolute value of A, and that B is a period factor such that 2 pi divided by B equals P. And you remember how the shift is related to the starting point, because we're going to be going backwards. We're going to be finding the starting point, and then we'll go backwards and find H and K. Okay, so the key thing here is if we know those three facts, we can graph or we can write a rule. We can go both ways because we know how the rules are related to the graphs. So in order to graph, you need to know, in order to write the rule, you need to know three things. You need to know the A value, the B value, the H and K value. And that should be pretty obvious because those are the four values that are in our rules. Now, what does that mean? That's fairly straightforward for sine because sine is the easier one if we look at especially the shift. The shift is H comma K, and that is directly related to the starting value for sine. But for cosine, it's different. So we need to remember that since that it's going to be different for cosine. One other thing that we need to remember is that since the absolute value of A is the amplitude, we won't always be able to tell from the graph if that was a regular 2 or negative 2 because the absolute values are identical. So in order to remember amplitude, we have to remember that A will be negative if the parent function is flipped. So typically I'll recommend that you try to find a starting point so that you won't flip the graph, but sometimes it makes more sense to write a rule such that we do flip the graph. And you'll see that when we start to talk about maybe the temperatures of values, because they start low in January and then they go up throughout the year and peak in July and then they come right back down. That's a cosine wave flipped upside down. So we'll take a look at that when we get towards the applications. But for now, we're going to mostly be dealing with amplitudes that are positives. So you'll see what I'm talking about when I talk about flipped when we look at the first example. So I'm going to fast forward here through what you saw in video 451. In video 451, we found the starting value, period, and amplitude for these graphs. Now what we're going to do is write the rule using those facts. So we already know all those things because we already did this in the previous video, but now we're going to write the rules. So the rules for these graphs, I got to fast forward a little bit more. So the rules, first of all, we have to remember our notes so that the starting point for sine waves, these are all examples of sine to start off, the starting point for sine is always H comma K. So 0, 0 will be our H and our K. The next thing we want to remember is that 1, the amplitude, is the absolute value of A. So again, is that positive or negative? We'll look at that in just a second. And the last thing that we need to remember is that the period is 2 pi divided by B. That's always how we find the period. So now we're going to work backwards and we're going to find the B, the A. We already know the H and K. So first of all, the period, 2 pi divided by B. So 2 pi divided by what will equal 2 pi? So 2 pi divided by what will equal 2 pi? Well, 2 pi divided by 1, of course, because the B won't really matter. So in this case, B is 1. The second thing we look at is the amplitude. Now the amplitude is positive 1 because as you can see the graph did not flip. So this is what I'm talking about with flip. If we look at the black line, it started going up just like the parent function does. It didn't start flipped going down. And so we'll look at that again when we get to applications. So now I write it in the rule. I know it's A sine of B x minus H, so minus 0, plus K. So I just simply plugged in 1 for A, 1 for B, 0 for H, 0 for K, and I'm done. So that is my rule for the first one. Now, of course, I can really simplify that. That's just the parent function. Hopefully we remembered that and we knew that, but that's how we'll find that. So let's take a look at the green rule for the next rule that we're going to write. So the green rule again, HK, if it's sine, H and K are exactly the starting point. Now for the period, notice that the period is 2 pi, so my period factor is 1 because the period did not change. And again, it's because 2 pi divided by 1 is 2 pi. 2 pi divided by B is the period. The second thing, though, the amplitude. The amplitude is the absolute value of A is 2. In this case, our A value is positive because it is not flipped. It's a normal graph of sine. Okay, so again, when A is negative, it's being the graph flips over. So the rule for this function, again, it's always A times sine, so A is 2, times sine of x minus h, and h is 0, and b is 1. So again, it's very simple rule. The only thing that's changed is A is 2 because h, k, and b are all the same as the parent function. Now the red rule, again, the red rule, h and k, 0, 0. Since my period is pi, 1 pi, 2 pi divided by b equals 1 pi, so b must be 2 because 2 pi divided by 2 is pi. So b must be 2. Now the amplitude is still 1, so my absolute value of A has to be 1. I want to make sure it's not a negative 1, so I just check my graph and I look and I see that it starts by going up, so it is a positive A value. So my rule starts with A sine of B. So 1 sine of 2, parentheses, x minus h, h is 0, plus k. Well, h and k are 0, 0, so those are really irrelevant, so my rule is just sine of 2x. Now what happens though, notice that remember we talked about in 451 that the video talked about how you could have started that red function where that pink curve is. And so if we look at those key points, that it was starting at pi and 0, still a period of pi, still an amplitude of 1, what would happen to the rule? How would the rule look different? Because this would also give you a correct answer for this question. So another solution would be that the rule is sine of 2 parentheses x minus pi, because the only thing that's changed, remember, is that the shift has changed. So the only thing that's different is that the h and k are different. The b is still the same and the a will still be the same. So this rule is also a correct answer to the problem. Let's take a look at a couple more examples with sine, just to make sure we've got the hang of it. We're going to look at 2 more examples here. Again, I'm going to fast forward through what we did in video 451, where we find all of the key information, like the starting points and the period and the amplitude. Rewatch 451 if you're not sure how to do that. So now, how does this make sense in my rule? So my rule, since the starting point is 0, 0, since we're writing sine rules here, that means my h and k are 0 and 0. That's nice. My period is 2, so to get the period, we always do 2 pi divided by b. So what does that mean for b? What's the b value? Now to solve this, sometimes you're going to have to do the following. You're going to have to solve this equation for b. So remember, that's simply solving by cross-multiplying and solving for b. So I cross-multiplied 2b equals 2 pi, and now I'm going to solve for b by dividing both sides by 2, and I get b equal to pi. So b is my pi. B is my period factor, and the value of that is pi in this case. Now the next thing I need to do is check the amplitude. Well, the amplitude is 3, so that means the absolute value of the A value is 3. Looking at my rule, notice I see that the graph goes up to start, so therefore my amplitude, my A value is positive. So I do want to check if it's positive or negative, and you'll see some ones that are negative in class tomorrow. So now I have everything I need to write the rule. I need these 3 things in green, so my rule starts with 3 sine, because 3 is the A value, and then I put the, now since h and k are negative, I'm not going to have parentheses inside the sine, but b is pi, so I put a and b in my rule, and I have the rule for this function. So now what happens for the black rule? The black rule, this one has a shift, a period, and amplitude. So notice the period is the same, so the shift hk will tell me the starting point. So those are identical to h and k. The period, 2, remember we just did that for the previous problem, so that means my b value is pi. And then the amplitude is 1. So I want to make sure that it's not negative. If I look at the rule and I go to my starting point, 1, negative 3, I see that the graph goes up at that point, so the amplitude is positive 1. The a value is positive 1 as well as the amplitude. Now I write my rule. So I start with a, which is 1, b, parenthesis, x minus h. So b was pi, and then my h is 1, and then I'm going to add on k, and k is negative 3, so that's why I wrote minus 3. So I put the h and the k in. Notice it's x minus 1, because it's always x minus h, and then plus k, and k is negative 3. So that is the rule for the black function. Let's take a look at the next set of examples. Now we're going to look at cosine. So you are going to have to do a cosine in your checkpoints. So again, I'm going to fast forward through finding all the starting, period, and amplitude. If you need help with that, we'll rewatch video 451. So now how does this work for, let's find the rule for sine, and then we'll compare that to the rule for cosine. So the rule for sine, remember when it's sine and cosine, they have the same period and amplitude because it's the same curve, with the starting point varies. So again, that's going to happen in my rule. I'm going to have the same a and b value, period and amplitude, but I'm going to have a different h and k value. So let's take a look at the sine rule. So h and k are 1 and 1. Since 4 is my p, my period, I'm going to solve the equation 2 pi over b equals 4 by creating equal ratios and cross multiplying, and solving for b by dividing by 4 and getting pi over 2, because 2 pi divided by 4 is 1/2 pi. So b is pi over 2. Now for my amplitude, again, I see that the amplitude is 1, but that means that's the absolute value of a. So in this picture, I check the graph. I'd make sure that it's going up, and I see at my starting point the graph is going up to start, so my a is positive 1. Now let's write the rule. So we have our a, b, h, and k. So our a value is 1, so we start with y equals sine of b. So that's b is pi over 2, x minus h is 1, and then plus k. K is also 1. So this is my rule for the black sine wave. Now what if I want to write a cosine rule for this same exact wave? So I've already got the key information, the starting, the period, and the amplitude. Now I'm going to find the rule. The rule starts again with a. We have to know h and k, but what we have to remember about cosine is that h and k is not equivalent to the starting point. Remember, the starting point is always h comma k plus a. That is how we find the starting point for cosine. So in order to find h and k for cosine, I need to use the value for a. So let's find the b and a and make sure we have those. So remember, since 4 is my period, my b value is pi over 2, just like the previous one, since it's the same wave. And the amplitude means that the a is 1, again, because it's going down to start, just like normal. So cosine, how do we find h and k? Well, h is identical to the starting point. So that 2 is my h value. But what about k? So k plus 1 has to equal 2, because the 2 value is my starting point here, and I need to get 2 by doing k plus a. I know a is 1 because I just found it, so I have to find out what k has to be. Well, k has to be 1 because 1 plus 1 is 2. So now I have my h and my k value, and I can write my rule. So my rule again starts with cosine of pi over 2, because pi over 2 is your b value. The a was 1, so I really don't need it in front. And then parentheses x minus h. Well, my h value is 2. And then I'm going to continue on and add k, so plus 1. So real quick before we move on to the next example, I want you to notice quickly how these rules are similar. Notice that they do have the same k shift, but they have this different h shifts. So they same b, same a, and even same k. It's the h shift that's different. So it's really important that you walk through these steps and are careful, because sine and cosine have similar processes but slightly different rules. Let's take a look at this last example, and then we'll get to your checkpoints. So again, I'm going to find the rule for sine. H and k are 0, 0. B has to be pi, because 2 pi divided by pi will give me 2. So I kind of solve that one in my head. And then my amplitude, oh, again, that means my period for my cosine is going to be identical, because I know they're going to be the same. My amplitude is 2, so the absolute value of a is 2. I check to make sure the graph is going up to start, and it is, so the a is positive 2. And the same thing for cosine. I'm going to check the amplitude. It does go up. It goes down to start, just like it's supposed to, so it's going to be positive 2 as well. So I have my b and my a value. I have my h and k for sine. So let's write the rule for sine. My rule is always a sine of b, x minus h plus k. H and k are 0, 0, so those don't really matter in this case. But pi is your b value, and a is 2. Now for cosine, so we have to remember that h is identical to your starting point for x, but k plus a gives you the 2. So again, what is the a value? The a value is 2, so 0 has to be my k value because 0 plus 2 is 2. So now I have the rule. I have 2 cosine of pi. Again, that's identical to the sine one because a and b are 2 and pi. But then I do have a horizontal shift of 0.5, so I have x minus 0.5. And then plus k. Well, k is 0 because, again, just like the previous one, k is 0 just like the sine value here. Because remember, we talked about k will have the same value, and because of what we discovered down here. So that's all there is for this video. Try the checkpoints, similar stuff. Your goal is to find, here's your multiple choice question, what is the b value for the black sine wave? Sorry, there's 2 graphs on there, but find the b value for the black sine wave. And then the free response question is to write a rule for the sine wave below. So you're going to try and write the full rule for that sine wave. These are the same checkpoints that you had for video 451. So hopefully if you have notes on those, you've already found some of the key characteristics just like we had in this video. So bring those questions into class and we'll see you tomorrow.